Hello friends, in this video I will illustrate how you can find distance traveled before a skidding when a car is moving in a circular path with a constant tangential acceleration. So problem says a car starts moving from rest with a constant tangential acceleration a1 along circular track of radius r. The friction coefficient between tires and the road is given, and that is mu. So we have to find the distance traveled by the car before it skids on the track. So what are the things that has been given? So we have been given tangential acceleration, that is dv by dt, and this is constant and the value is given a1. And the particle is at rest at t is equals to 0. So let us say particle starts or car starts from this position and this is going in this direction, and initially speed is 0, but it has a constant tangential acceleration a1. And this radius is given, so this radius, let's call this radius is r. So radius of circular path is given. And the friction coefficient is also given, so mu is given. So we have to find distance traveled before it just starts skidding. So let us say when car reaches at this position, it starts skidding. This means I have to calculate this distance. What is this distance? So let us try to see what are the forces that is acting and what are the acceleration that are present. So let's say at this point of time there are two acceleration. One component of acceleration, this is in this direction and this is radial acceleration. Another component of acceleration we will have, that is in this direction, this is tangential acceleration. Now you see this is a different. Initially in uniform circular motion, most of the time you see there is no tangential acceleration, that is at is equals to 0. But in this case at has a value and this value is a1. So this means what will be the resultant acceleration? So in this case the resultant acceleration will be, so you will have something like this, and the resultant acceleration will be in this direction. So resultant acceleration you can show, this will be in this direction. So this is the resultant acceleration direction. So this is A. So what is the direction of friction forces? Now the friction forces also has to be in this direction, because friction force is the only force that provides acceleration in both directions. So this means my friction force for this car is also acting in this direction. So friction force is acting in this direction. So let us say friction force magnitude is F, and that will be mu times N. So friction force is acting in this direction and magnitude will be mu times N, and N in this case is nothing but equals to mg. Now you have to find distance traveled. So the maximum friction force required you can calculate either using this, or you can also calculate this friction force, that is m times a, mass times acceleration. And acceleration, there is two components of acceleration, so you will have radial acceleration and tangential acceleration. So you can calculate the resultant accelerations. So once you have this acceleration, you can calculate this friction force. And this friction force is provided by mu times n. So in limiting situation, what you will have these two things equal. In limiting situation, mu n is equals to ma. So using all this hint, let us try to solve this problem. So I hope you solve this problem. So let us see the solution now. So if you solve this problem, What are the things that is given? So we have been given dv by dt is equals to a1. So what I will do is I will make a variable change. So I can write dv by ds times ds by dt is equals to a1. And ds by dt is nothing but v. Simply this is the tangential velocity. So we can write this v times dv by ds is equals to a1. So I can integrate this. So I can write v dv is equals to a1 ds, and t is equals to 0, or when s is equals to 0 at this position, in this case at this position, when s is equals to 0, velocity is 0 because it has been given that it starts from rest, and this is s, then velocity is v. So we can write v square is equals to 2a1s. So now I know what is the velocity. So I will use this velocity, that is 2as, to calculate the radial acceleration. So what will be the radial acceleration? So if you remember, radial acceleration is nothing but v square by r. And v square in this case 2as, and this divided by r, this is the radial acceleration. What is the tangential acceleration? So this is given a1. So we can find total acceleration. This is basically root over ar square plus at square. So this term will be simply a is equals to ar is 4a square s square divided by r square, and this is a1 square, and this is 4a1. So let's write everywhere a1. So this is a1. So this is a1, this is a1. So you can take a1 common. So acceleration a is equals to a1, 1 plus 4s square divided by r square. So this is the acceleration. So what is the friction force required to have this motion? Mass times acceleration, that is mass times a1, a square root of 1 plus 4s square divided by r square. But now this friction force that is required, so this much friction force is required to have this motion. And from where this force will come? This force will come from mu times n. So in limiting situation, you have to have mu times n is equals to this value, and n is nothing but mg. So mu mg is equals to ma1, a square root of 1 plus 4s square divided by r square. M cancels out. So from here you can calculate s. So this will be mu g by a1, a square is equals to 1 plus 4s square by r square. So or you can write basically 4s square by r square. This is equals to 1 minus mu g by a1 whole square. So s is equals to r by 2, a square root of 1 minus mu g by a1 whole square. So this will be value of distance traveled. Basically there is a mistake here. So this will be minus 1, and then this will be minus 1. So this is minus 1 plus this. So you will have s is equals to mu g by a1 whole square minus 1, a square root of this, and then r by 2. So this is the maximum distance traveled by the car before a skidding takes place. Now I have a question for you. So let us say in this case the motion is taking place on a simple circular track, that is horizontal circular track. Now let us say if this motion is taking a track that is inclined or banked. Let us say the banking angle is given, so this angle is theta. Now in this case this car is moving here, and tangential acceleration is again a1. Now this speed will be increasing because there is a tangential acceleration. So a time will come when this will start skidding, because the friction coefficient is also given mu, and this is moving in a circular track of radius r. So this is on a circular track of radius r. These things are given. Now the question is, where will be the changes that will occur in the previous method of solution? Will the normal reaction be mg? Do I have to take the component of friction forces along the incline? How we will write the equation of motion in the radial direction and tangential direction? So let us discuss some of these in the comment box, and I will see you in the next video.